Welcome to our channel. Today, we're diving into the fascinating story of NGC 2808, a globular cluster that has left astronomers puzzled and amazed. What makes this cluster so intriguing? It's the discovery that within the first 200 million years of its formation, not just one, but 3 generations of stars were born. Let's explore this cosmic marvel. Located about 31,300 light-years away in the constellation Carina, NGC 2808 is one of the most massive globular clusters in our galaxy. This tightly packed collection of stars is estimated to be around 12.5 billion years old, forming during the early stages of the Milky Way's evolution. Typically, globular clusters were thought to form a single generation of stars, all born from the same cloud of gas and dust. However, NGC 2808 defies this conventional wisdom. Studies using the Hubble Space Telescope revealed that this cluster contains 3 distinct populations of stars, each with different chemical compositions. The first generation of stars formed from the primordial gas that remained after the Big Bang. These stars were composed mostly of hydrogen and helium, with very few heavier elements. But something extraordinary happened after this initial burst of star formation. As these first-generation stars evolved, they began to expel gas and heavier elements through stellar winds and supernova explosions. Surprisingly, instead of dispersing into space, much of this material was retained within the cluster. Over time, this enriched gas cooled down and triggered the formation of a second generation of stars. The second generation stars had a different chemical composition compared to the first. They contained heavier elements, or metals, like carbon, nitrogen, and oxygen, which were produced by the earlier stars. But the story doesn't end there. A third generation of stars formed within the first 200 million years of NGC 2808's existence. These stars were even more enriched with heavier elements, showing that the cluster had gone through multiple cycles of star formation. This multi-generational formation process is a rare phenomenon among globular clusters. So, why did NGC 2808 experience this unusual process? One theory suggests that its massive size played a key role. The cluster's strong gravitational pull might have allowed it to hold onto the gas and dust expelled by the earlier generations of stars, fueling subsequent star formation events. Most globular clusters in the Milky Way have only 1 or 2 generations of stars, making NGC 2808 a remarkable exception. Understanding its formation helps astronomers gain insights into the complex processes that shape star clusters and the early history of our galaxy. NGC 2808 remains an object of intense study, as it challenges our understanding of star formation and the life cycles of globular clusters. The discovery of its 3 generations of stars shows that the universe is full of surprises, even in places we thought we knew well. If you enjoyed this exploration of NGC 2808, don't forget to like, subscribe, and hit the bell icon for more fascinating journeys through the cosmos. Thanks for watching, and until next time, keep looking up at the stars.